Today we'll see the hierarchical clustering. What are the different types of hierarchical clustering? So as the name indicates hierarchical, it creates the hierarchy. We may have some tree-like structure, so it creates a hierarchical structure or hierarchical decomposition. Now there are majorly two types of hierarchical clustering: agglomerative clustering and divisive clustering. The agglomerative clustering is also called as bottom-up approach. The basic aim is to form the clusters. So in agglomerative clustering, we'll have to start from the bottom. That is, we have to start with each object as a separate cluster, as a separate group. So let's say if we have 10 data objects, at the start we are having 10 different clusters, 10 different groups. And after that, successively we are going to merge these data points based upon some similarities. We'll merge the data objects, or we may have the new clusters after grouping these data points at the second level, and so on. We are going to merge these clusters together to form the larger clusters. So this merging process goes on continuing, and at the topmost level of this hierarchy we'll have the finalized clusters, and we have to continue this process until a certain termination condition occurs, or we have not obtained any changes in the clusters. So this is how the agglomerative clustering works. Let's see in the figure. In this we have this A, B, C, D, E as the data points, data objects. Now at the step 0, each individual data points are considered as a separate cluster. In the step 1, I have merged A and B together. In the next iteration, I have merged D, E. So now at this phase, I have A, B and D, E as the two clusters and C as the individual cluster. At the step 3, again C is combined with the cluster DE, so the larger cluster formed is CDE. And at the step 4, we have the ABCDE cluster. So this is how the agglomerative clustering works from bottom to top. The special algorithm for this is AGNES. It is the type of agglomerative clustering. Okay. The second type of this hierarchical clustering is the divisive approach or divisive clustering. This clustering is also called as top-down approach. The top-down approach, obviously it starts from the top, so all these objects are considered as a part of a single cluster at the start, and then successively at each iteration we split these larger clusters into the smaller clusters. So this is an iterative process. We go on dividing, splitting the clusters into small, and this process again continues till some termination condition occurs, or we have to stop when there are no changes in the successive clusters formed. So this is how this divisive approach works. So in this figure you can see it is opposite to agglomerative. So how it will work? So it will start at the step 0 with all data objects as a single cluster. In the second iteration, step 1, we have divided this into two clusters. One cluster is CD and second cluster is the AB. At the next step 2, we will divide the CDE cluster into two clusters, that is, one is C cluster, another is the DE cluster. And so on, we are going to divide the successive clusters, and this is the last step of this DINA or divisive clustering algorithm. Now in this example, we are having every data objects as an output. This is an example. So always you will not get a single cluster at the or end of this agglomerative clustering, or you will not always get this individual data points as individual clusters in the divisive or DINA algorithm. This is a generalized example for the explanation. Now the hierarchical clustering methods can use the distance based or density based or continuity based. That means we can use any of these three for identifying the similarity between the data objects, and based upon that we will have the clusters forming. For example, distance based will use the Euclidean distance. If there is a minimum distance between two data objects, they are merged into the same cluster. If there is a larger distance between two data points, they will not fall under the same cluster, they have the different clusters. So similarly, we can use the other approaches like density based or continuity based for forming the clusters. So same what we have explained is on the slide, AGMES. It is introduced by the Kaufman and Joseph. So it is implemented by using one statistical analysis package. For the example is S plus. It has already implemented all the statistical analysis, mean, median, mode, and based upon that it works for the agglomerative clustering. We can use the single link method and the dissimilarity matrix for forming the cluster. So in dissimilarity matrix, we have seen the distances between the different data objects are marked. Diagonally, we are getting all zeros. So with this diagonal values are 0 in this dissimilarity matrix, and we are getting some distance values. So the distance between 1 and 2, 1 and 3, 1 and 4. So based upon this, we can have the clusters formed. We go on merging the clusters and will have the different clusters at this. So this is how the agglomerative or AGNES algorithm works. So does the bottom-up approach starts with each object. It starts with each object as a own cluster, and then we are iteratively merge these small clusters into the larger clusters. So until we get a single cluster or some stopping criteria is reached, or we may have the same cluster generated in the consecutive iterations, so we'll stop. So if there is a single cluster, it becomes a hierarchy's root. So this process of merging goes on, and we'll have the different clusters or one cluster at the top. Now the DINA or divisive analysis, it is again given by the Kaufman and Rose. Again it uses the statistical analysis package S plus, so we can have the direct implementation of this algorithm. It is inverse order of AGNES algorithm. So eventually we may have the larger clusters at the start, then we are going to split them into the small clusters. Again we'll have the splitting of the clusters, and at the end we will have the clusters maybe of the smaller size. So each node forms a cluster on its own, or you may have the different clusters at the end of this. So this is how the Dyna algorithm works in the top-down strategy. So it starts by placing all objects in one cluster and then go on successively dividing the clusters into the smaller clusters. So this is a repetitive process. So it continues until each cluster have the at the lowest level. It may contain only one object, or it may have the sufficient number of objects as to form a cluster.